Welcome to Educoun Digital. My name is Amit and today I am going to explain you the concept of orthographic projections from the subject engineering graphics, or you can call it as engineering drawing. This concept is very important as far as this subject engineering graphics is concerned. But before going into the details of this topic, that is orthographic projection, we are going to understand a simple term called as projection. So what is projection? You can see on the screen the definition of projection is transfer of image. So what is the concept of transfer of image and how it is done? This we can see with a simple example of imagining a man or a person standing in a room which is full of darkness. A provision is made that not a single ray of light enters into that room. What will happen? The man standing in the room cannot see the object around him due to absence of light, because the light enables us to see the objects around us. Now suddenly, if the lights in the room are switched on, what will happen? The light rays from wherever they are coming fall on that person's body and his shadow will be casted on the wall either in front of him or to the wall to the right or left of him, or he can see the shadow on the floor or anywhere in the wall. So this is the concept of transfer of image. What exactly happens? The light rays transfer the image of the person onto the wall in the form of the shadow. Where exactly will the shadow will get casted? It depends upon the direction of rays of light from wherever they are coming. So it is the simple logic that if the light rays are coming from the top, that is from the roof, the man will see his shadow on the floor. If they are coming from the front side of the man, his shadow will be seen on the back wall. If the light rays are coming from the left side, the shadow of the man will be seen on the right side. And if the light rays are coming from the right side, the shadow of the man will be seen on the left side. So this is the concept of transfer of image, in which the image of the person is transferred in the room or on the wall or on the floor in the form of a shadow. So let us move to the next concept, that is, what are the types of projections? The projections are categorized into two types. One is orthographic projection, which is also called as 2D projections or two-dimensional. Another is isometric projections, that is 3D. So now what is orthographic projection? Orthographic projection, it is a two-dimensional representation of an object. And what is isometric projection? It is a three-dimensional representation of an object. In orthographic projection, a 3D object is given to you as a question and you have to obtain the two-dimensional views out of that. But while attempting an example of isometric projection, 2D views are given as a question and you have to draw a real 3D object from the information given in the form of 2D views. So you can conclude here that orthographic and isometric projections are reverse procedures of each other, just like derivatives and integration in mathematics. As it is said that integration is called as antiderivative, it is reverse procedure of derivative. The answer of derivative is a question of integration and answer of integration is a question of derivative. Same is the case with orthographic projection and isometric projection. It is analogous concept. Whenever you are converting 3D object into 2D views, then you are doing orthographic projection. And whenever you are converting 2D views into 3D real object, you are attempting an isometric projection problem. So this is the basic difference between orthographic projection and isometric projection. Now let us understand orthographic projection in detail for simple machine parts. So whenever you are doing an orthographic projections, we have to use two methods. Method number one is first angle method of projection and second method is third angle method of projection. Now we will discuss these methods in detail in the next slide. So what is first angle method of projection? Whenever the object is kept in the first quadrant, or you can say it is assumed to be kept in the first quadrant, then the method is called as first angle method. Now, if the same object is kept in the third quadrant, or it is assumed to be kept in the third quadrant, the method of projection used is third angle method of projection. Now, what do you mean by quadrant? Whenever a three-dimensional space is divided into four different regions by intersection of a vertical and horizontal planes which are exactly at 90 degrees, that is perpendicular to one another, the regions so formed are called as quadrants. You can see the figure in the slide. The intersection of planes is shown there, and the regions formed are first quadrant, second quadrant, third quadrant and fourth quadrant. This you can see with another perspective, just like you can see the 2D figure of that planes are representing the lines. Now there is a vertical line and horizontal line separated by four regions. You can see quadrant number 1, quadrant number 2, quadrant number 3 and quadrant number 4 figure at the right side of the slide. Now, first of all, quadrants are made of three planes. Now, if it is first angle method of projection or third angle method of projection, any method you choose, quadrants will be made of three planes. These three planes are called as the reference planes. Which are they? Let us see. You can see the figure in the right side. The plane number 1, that is vertical plane, also called as the frontal plane. Short form you can use here VP or FRP. FRP stands for frontal reference plane or VP stands for vertical plane. The second plane is horizontal plane, that is HP or HRP. You can see horizontal reference plane or horizontal plane HP. The third plane is profile plane, that is called as PP. Now, these three planes in that particular quadrant are mutually perpendicular to one another, which means they are forming 90 degrees with one another. You can consider or imagine these planes as that the example given earlier, a man standing in the room. The wall in the room, the vertical wall in the room will act as VP. The floor we will consider it as HP, or any wall in the side, that is right side wall or left side wall, you can consider it as PP. So, the quadrants are made of three planes and these three planes are called as reference plane or principal planes. Okay, let us move to the next slide. We will see the first angle method projection, first angle method of projection in detail. Now, in first angle method, following sequence is very important. So, first comes the observer, then comes the object and then comes the reference plane. Now, this we can understand with the help of the figure shown in the right side of the slide. Now, you can see this sequence in the front view as well as in the side view as well as in the top view. Now, if you consider the front view, that is, it is shown the observer's position, indicating the arrow is shown there. So, always in first angle method of projection, observer comes first, followed by object. The object shown here is a cube, is exactly placed in that quadrant. So, observer followed by object and last, that is reference plane. The reference plane is here VP, vertical plane. Now, if you see the same object, that is the cube, from the right side view, again same sequence you have to follow. Observer, the object and the plane, but the plane here will be profile plane rather than the vertical plane. And same thing is from the top. Same sequence is again observed in the top, that is top view observer, then the object, that is the cube, and plane will be horizontal plane now. So, this sequence is very important as far as first angle method of projection is concerned. Now, we can have some conclusions. Now, whenever the views are obtained, the 2D views from the 3D object are obtained on that respective principal planes, the view observed on the vertical plane is called as the front view. Now, since this is a cube, you are going to see the shape of the square in the front view. So, view observed on VP is what? Front view. Next conclusion is that view observed on the horizontal plane is top view. If you see the same cube from the top, again you are going to see the square shape, and same shape, that is square, is seen in side view, and which will be obtained on which plane? That is profile plane. So everywhere you are going to obtain the same shape, that is true shape on VP, PP and HP. Okay, in front view, top view and side view, square will be obtained. So these are the conclusions while doing first angle method of projection. Now one more important concept you have to understand here. So after the projections are obtained or after the views are obtained on the three principal planes or the respective principal planes, what exactly is done, that keeping VP as it is, you have to rotate horizontal plane, that is HP, and profile plane, that is PP, in 90-degree clockwise. So rotate HP and PP 90-degree in a clockwise direction to form a plane paper system. So in the plane paper, whenever the plane paper system is formed, HP and PP comes in the same plane as that of VP, and they are one above or below the other or side of each other. And you can see whenever the plane paper system is formed, HP, when it is rotated 90-degree clockwise, it just goes below VP, and PP, after rotating it in 90-degree clockwise, it goes to the left of the VP. And the views obtained, now front view will be above, followed by top view will be below front view, and that right hand side view, it goes to the left hand side of the front view. So this plane paper system is to be formed by rotating HP and PP in clockwise rotation 90-degree. Let us move to the next slide, and we can see the positions of the respective views with respect to that reference line, that is called as XY line. So this figure shows the XY line, which is a reference line, and you have the following conclusions after that plane paper system is formed. What are the conclusions? Front view is always seen above the XY line. Then top view is seen always below the XY line, and it is always below the front view. What about side view? Depending upon which side view it is, right side view or left side view, it is always above the XY line. But right side view is always to the left of the front view, and left side view is always to the right side of the front view. So these are the positions obtained for different views considering first angle method of projection. In short, front view and side view are above XY line, top view is below XY line, and right hand side view is to the left and left hand side view is to the right. So this is the entire concept of first angle method of projection. Now considering the third angle method of projection, the object is kept in the third quadrant, but we are not going into much detail of that because it is not included in your syllabus. Now very important concept we have to study is that in different views what dimensions are observed. So whenever you are seeing the object from the front, that is in the front view, you are going to observe only two dimensions, that is length and height. Now going to the side view, we are going to see only width and height, and in the top view you are going to see only length and width, which means that each view has one dimension missing. Front view you are not going to see width, in side view you are not going to see length, and the observer of the top view is not going to see height in any case. Since this is a 2D projection, in each view only two dimensions are obtained. In short, front view has length and height, side view has width and height, and top view has length and width. So now let us study some characteristics of views. So important thing here is obtaining of the true shape of the section. So how this true shape is obtained? First is, if the plane of the object is parallel to vertical plane, that is VP, we get the true shape of that plane in front view. Now if the plane of the object is parallel to HP, we get the true shape of that plane in top view. And if the plane of the object is parallel to the profile plane, that is PP, we get the true shape of that plane in side view. So the conditions for obtaining the true shape is that the plane of the object should be parallel to any of the reference plane, that is HP, VP or PP, and then you are going to get the true shape of that plane or that object's plane. Now One more important thing I want to add here, if the plane of the object is not parallel to any of the reference plane, we always get the reduced shape. We are not going to get true shape there. So for obtaining true shape, plane should be only parallel. Now, what are the important points to be remembered while drawing an orthographic projection of simple machine parts? So here the question in the form of a 3D object is given in front of you. What you have to do is, you have to decide which side view is to be drawn according to the position of the arrow which indicates the observer. So observer will always indicate the front view, and according to that we have to decide which side view is to be drawn. If first angle method you are using, then for first angle method, if RHS view is to be drawn, it should be at the left side of the front view, and if LHS view is to be drawn, it should be right side of the front view. So it is totally dependent upon the position of the arrow given in the question, that is the position of the observer which indicates the front view, and you have to identify the side view. Now your next step is that finding the maximum dimensions of the object. The maximum dimensions of the object are length, height and width. Total length, total height and total width of the object is calculated. Now after that, after identification of the side view and the overall dimensions, what you have to do is, you have to draw 3 reference lines. You can also see the figure in the right side. 3 reference horizontal lines and 3 reference vertical lines at a spacing of 10 mm, and this 10 mm gap should be maintained throughout. It is shown in the figure in the right side. So keep 10 mm distance between these lines. These lines should be perpendicular to one another. One more thing I want to add here, at the middle vertical line or at the intersection of middle vertical line and middle horizontal line, there is letter O as shown in the figure, and from that letter O you have to draw a 45-degree line passing through the diagonal of the lower square. It is shown in that figure also. So this 45-degree line is also a reference line. It should be below the side view, and this line is used for the purpose of transferring the dimensions from one view to the another, rather from top view to side view or either side view to top view. So this is the purpose of this line. So after this, what we have to do is, we have already measured the maximum dimensions, that is length, width and height of the object. Now draw the rectangles in each view in the section, in the portion shown there, which is divided by the 3 vertical and horizontal lines. That is, you can see, if you have identified that RHS view is to be drawn, then it should be in the left section. It is shown that RHS view is left to the front view in the figure. Top view is exactly below front view, and below RHS view there will lie a 45-degree line as shown in the figure. So now what we have to do is, draw the rectangles in each view considering their dimensions. That is, in front view you have to draw a rectangle of length and height. In the top view you have to draw the rectangle of length and width, and in the side view you have to draw the rectangle of width and height according to the question. So after drawing the rectangles, make sure that all the lines you have drawn are light in thickness, that is, they should be faint lines, as these are construction line used for the construction purpose only. And then divide the machine parts or the given object into number of small parts, including the surface changeover, and make the required portions, that is the outline, dark. And you can see now the rectangles will be made dark after that. So now main machine parts observed in most of the example or maximum examples are horizontal plate, then vertical plate, rib and cylinder. So these are the common machine parts observed in most of the examples of orthographic projection. One more important thing is that always start from such a view in which circular parts can be seen in the form of a circle. For example, cylinder. If cylinder is kept on the ground, you can see the circular part or circle in the top view. So in this case, while drawing an orthographic projection of a cylinder, you will start from the top view because a circular part in the form of circle is seen in the top view. Now let us move to the next slide and we are going to discuss some machine parts that are common in most of the examples. So first machine part is, we will see horizontal plate. Now you can see the figure of the horizontal plate in the right side. According to the guidelines or points just now we have discussed, you can see in the figure the position of the observer is given. That arrow indicates the position of the observer and always the arrow indicates the front view. According to this position, we have to identify which side view is to be drawn in this particular problem. Now what are the maximum dimensions of this plate? So length of the object which is observed in the front view is 100, height is 20 and width given is 60. You can easily identify. Now according to the arrow shown, the arrow will indicate front view and here RHS view is required. You have to draw right hand side view. Now you can see, since this is a horizontal plate, all the planes which will be seen in three views, that is front view, top view and side view, are parallel to the respective reference planes. Therefore, all the rectangles that are seen in each view are true shapes, because the condition for obtaining true shape is that the planes should be parallel to the reference planes. And here we are getting true shapes in all the three views. You can see the solution there. So how to start the problem? First, to draw the three horizontal reference line, then three vertical reference line. At the intersection of middle vertical line and middle horizontal line, there will be letter O, and from letter O passing through the diagonal of the square, you have to draw a 45-degree line there. This is used for the purpose of transferring the dimensions from top view to side view or either from side view to top view. After this step is over, you have to mark the position of each view in their respective places. Now according to the first angle method of projection, right hand side view will be in the left side and front view will be in the right side, and below front view there will be top view, and that 45-degree line will be below side view always. Now we have to draw the rectangles of required dimensions. That is, in the front view you have to draw the rectangle of 100 by 20. In the top view you have to draw a rectangle of 100 by 60, that is length and width, and transfer that width to the side view by use of that 45-degree line. That is, width 60 should be transferred by making the use of that 45-degree line, and side view will be having a rectangle of 60 by 20. So now you can see the solution of this problem in the figure. It shows front view, side view and top view in the form of true shapes as a rectangles. After doing this, add the dimensions to that views. That is, height you can see in the front view 20 is given there, 100 length is given in the top view and 60 width is given in the side view, and make the required rectangles dark now, as they are the outlines of that surfaces seen in each view. So this is the first problem, that is horizontal plate. Now let us see one more machine part, that is cylinder. So now you can see the figure of the cylinder again in the right side of the slide. The position of the arrow there indicates the observer, and that is the front view, that is pointing the front view. Now according to the position of observer given, here again like the previous example, RHS view is required, that is right hand side view is required here. What are the overall dimensions of the cylinder? Let us see. The height of the cylinder is 100, width and length are exactly equal to diameter, that is 60. This is because when you see the cylinder from the front, the diameter acts as a length, and if you see the same cylinder from the right hand side, the diameter will act as a width. So width and length are same, that is equal to diameter of the cylinder, and that is given as 60 here. So overall dimensions are 60 by 60 by 100. Now, whenever you are drawing a projection of a cylinder, circle is seen in the top view. As you can see in the figure in the right, top view's observer, in the top view you are going to see the circle. So, always start with that view that is having a circle. So, we have to start with top view in this drawing. You can see the solution of this problem, that is cylinder. So, now we are going to start with top view. Again, we have to follow the same guidelines: 3 horizontal reference line, 3 vertical reference line, letter O, 45-degree line. But you have to also give the positions or positions of the views in their respective places. That is, front view here should be at the right side, right hand side view in the left side, and top view exactly below front view. And then 45-degree line will be always below the side view. Now, after doing this, draw all the 3 rectangles representing each view with their respective dimensions. That is, again, length and height in front view, width and height in side view, and length and width in top view. And you have to start with top view by drawing a circle of diameter 60 or by radius 30. After drawing a circle, you have to draw the center line in the middle and transfer that center line in the front view as well as side view. And then diameter 60 is to be transferred to the front view as well as side view. Make the required rectangles dark, and you are going to see 2 rectangles in 2 views, one rectangle in 2 views, and in the top view you are going to see a circle. So, whenever you are drawing a cylinder, a circle is seen in one view, and other 2 views you are going to see a rectangle only. Here front view and side view shows the rectangle and top view shows the circle. Now, let us move to the next machine part, which is called as a rib. So, what is a rib? You can see the figure in the right side again. Rib means it is a solid material used to give support to a machine part. A machine part, whenever it is under loading, rib adds strength to that machine part. A rib is a separate part which is separately welded to a machine part, just to add the strength and withstand the load. So, this is the function of the rib. Now, in the figure shown in the right side, arrow indicates the position of the observer, which will be the front view. According to this, again, you are going to require right hand side view here. Now, what are the overall dimensions? Overall dimensions of rib are: height of the rib is 70, width is 20, and length is 70. Now, rectangle of 70 by 20, which is the inclined plane, it will be observed in 2 views and without a true shape. Why this is so? Because that plane is inclined. It is seen in right hand side view. You can see the plane, which is an slant plane of 20 by 70. The rectangle will appear as a reduced shape in 2 views. Since the plane is inclined, we are not going to see the true shape. Only the true shape here will be obtained in front view, that is the triangular shape seen in the position of the observer. You can see the solution. Again, same guidelines to be followed, which we have discussed earlier. After doing that, after drawing the main rectangles, then what we have to do? Draw the shapes in the front view, top view, and side view. Here you are going to see a triangle shape in front view, and rest 2 views, that is top view and right hand side view, will have a rectangular shape, and that will be reduced shape. Only the true shape obtained here is seen in the front view, which is a triangle, and the rest all 2 shapes, that is rectangles, are the reduced shape. Let us move to the next part, that is vertical plate, or you can call it as a vertical semicircular plate, as there is a semicircle at the top. Now, these are the overall dimensions with the position of the observer is given. So, now you can see clearly here, that is length is 20, width is 50, and height is 95, and the radius of that semicircle is 25. Now, according to the position of the observer given here, you have to draw the left hand side view. Left hand side view is required. Now this is the solution of this vertical plate. Now since that semicircle or circular part is seen in the LHS view, you prefer LHS view for starting the drawing. Rest the guidelines, follow the each and every guidelines that are explained earlier. Then after drawing the outlines of this, give the dimensions to the object. But now you can also see one more important thing which I want to add is, in the left hand side view, actual profile of the semicircle is seen. And in the front and top view, we are going to see the rectangles there. Now you can see the object from the top, it is a curved surface. Even if it is a curved surface, it appears as a rectangle of 20 by 50, and same is the case with front view. Again in the front view, there is a curved surface, but still it appears as a plain rectangle of 20 by 95. So let us see the concept of the hidden part. So hidden part is always shown by the dotted lines, and when there is a surface changeover in any object, dark or dotted lines are to be drawn depending upon visible or invisible portion. If there is a surface changeover of a visible portion, then dark line is drawn, and if there is a surface changeover indicating the invisible portion, a dotted line is preferred, and dotted line is called as the hidden line. Now see the figure in the right side. It is a hollow cylinder with circular hole. Again the position of the observer is shown, which will be indicating the front view, and according to this we have to draw the right hand side view. The overall dimensions of this hollow cylinder are, height of this cylinder is 80, width and length are same, equal to the external diameter, that is given as 60 here, and internal diameter of this cylinder is 40 mm. Now whenever you are drawing the three views of the cylinder, one view is circle and other two are rectangles. Now here the two rectangles with dotted lines you have to show, which will represent the hidden part of this object. You can see the solution here shown in the figure. So always start from that view which is having a circular part. We have to choose the top view here, since the circles are seen in the top view. So after drawing the two concentric circles in the top view, you have to draw two rectangles in the front view and side view. Make the outline of the rectangle dark and draw two dotted lines which represents the hidden hole. The hole is not seen in front view as well as side view, so it is represented by hidden line. You can see the color of the hidden line given here as a green color. So hidden lines will represent the invisible portion. So this is the concept of the hidden part. Now let us move to the next machine part. So this figure you can see in the right side of the slide. This is a C-shaped slot. So how to calculate the overall dimensions? Length of this object is 60. Because direct length 60 is not given here, you have to add 20 plus 20 plus 20, that is 60. Height is 40 and width is 100. Again the position of the observer will indicate front view, and according to this we have to choose left hand side view. Now there are certain numbers marked on different surfaces of these C slots. These numbers indicate the individual surfaces of that slot and indicating the surface changeover. Now the surfaces seen in the side view are two, that is surface number 1 and surface number 6, in which surface number 6 is a hidden surface which will be not seen in the side view, but you have to represent it by dotted line. The surface seen in the front view is surface number 2, which is the entire C-shaped slot. There is only one single surface in the front view. And if you consider top view, if you see the object from the top, you are going to observe three surfaces from the top. Surface number 3, surface number 4 and surface number 5. That are the three rectangular strips which are seen from the top. Now here the surface number 3 and surface number 5 are in same plane, but surface number 4 is just below 20 mm from that. But while drawing the actual views, your solution will be like this. Again, the same guidelines you have to follow that were discussed earlier, that drawing of the 3 reference line, horizontal, vertical, then give the names of the views in their respective places, and below the side view always draw the 45-degree line for transferring the dimensions. Now here in the front view, you are going to see the surface number 2, which appears as a C-shaped slot. Side view will be appearing as a rectangle with a hidden line just 20 mm below from the top, which will represent the surface 6, that is hidden line. That is shown by the hidden line. Now in the top view, 3 rectangular strips are shown there. And since 3 and 5 are in same plane, but the surface number 4 is just below 20 mm from 3 and 5, but one dimension is missing in each view, you are going to see these 3 planes, that is surface number 3, 4 and 5 exactly in a same plane. So this is the solution of C-shaped slot. Now let us move to the next slide. You can see the C-shaped slot again, but it is inverted now, kept upside down. Here, according to the position of the observer, left hand side view is required. The overall dimensions of this are: length is 60, again 20 plus 20 plus 20, height is 40, and width of the object is 100 mm. So same object is compared to the last example, but it is now inverted, kept upside down. Top view becomes invisible. The visible portion in the top view here will be invisible now, shown with the dotted lines. You can see the solution. C-shaped slot in an inverted position is seen in the front view. The same rectangle like the previous example in the side view is shown. In that rectangle, a hidden line is shown just below 20 mm from the top, which will represent the invisible surface. And in the top view now, the surface changeover is indicated by hidden line instead of dark lines, because the portion of that slots are invisible in the top view. So 2 hidden lines are shown 20 mm apart from each other in the top view. You can see that in the form of dotted lines. So this is the solution of inverted C-shaped slot. Again, in the next machine part, a C-shaped slot is shown, but the slot here is made inclined. Now you can see the position of the observer indicating the front view, and according to that, LHS view is required in this drawing. Now what are the maximum dimensions again? Maximum dimensions are: length is 60, height 30 and width 80. So difference in the slot compared with the last example is that due to an inclined slot, there will be 4 dotted lines in the top view at 30 mm from the bottom and 40 mm apart at the height of 15. And these are shown in the solution, you can see that. So instead of 2 dotted lines in the top view, there are 4 dotted lines, which will be indicating surface changeover of the invisible portion in the top view. Again, the left hand side view is same as that of the previous example, a rectangle with hidden line shown at 15 mm from the top. And in the front view, the C-shaped slot is shown, but the slot is inclined here, which will be 30 at the bottom and 40 mm at a height of 15. So in this way, you are going to complete the drawing of this C-shaped slot and then add the respective dimensions. Then in the next slide, so this is the last machine part we are going to see. Now this machine part shown here is a combination of 2 parts. One is L-shaped bracket, and to the L-shaped bracket a rib is fixed there. So this machine part is made of rib as well as L-shaped bracket. Now how to find the overall dimensions of this? Length of this object is 60, that is the diameter of the semicircle. You can see the semicircle's radius. It is given in the question, that is R30. So, diameter, that is double of radius. The diameter is 60. Therefore, the length of the object is 60. How to calculate the width? Width is not directly given here. You have to calculate the width step by step. As the width is seen in the top view as well as in the side view. You can see in the top view that first you take the radius of the semicircle, that is 30. Then from the center of that semicircle, if you see from the top to the end of the rib, the dimension given is 40 there. So 30 plus 40 and followed by 20 mm thickness of that L-shaped bracket. So 30 plus 40 plus 20. So overall width is 90. Now if you want to calculate the overall height, what are the dimensions there? L-shaped brackets thickness, that is 20, which will come first. Then again starting from the ribs bottom to the center of the semicircle, that is 40. And from the center of the semicircle, radius of the semicircle is given as 30. So if you add 20 plus 40 plus 30, the overall height of the object comes out to be 90. According to the position of the observer shown there, it will be indicating the front view, and according to this front view, RHS view is referred, or RHS view should be preferred here. You can see that 30 is the radius of the semicircle. According to that, diameter will be 60. So no hidden parts are there in this object. Entire views will be shown by the visible part. The solution is shown here in the figure. You can see that there is a combination of two objects, that is rib and L-shaped bracket, and there is a surface changeover while considering the L-shaped bracket. That you have to draw the projection of L-shaped bracket first and then you go to the rib. Rib should be drawn at the last. So where is the surface changeover? In the front view, there is a surface changeover from 20 mm dimension is shown, which is indicating a dark line, which will be shown as a curved surface, and then the back wall. Same surface changeover is observed in the top view at 20 mm. It is shown by the dark line as far as L-shaped bracket is concerned. And after L-shaped bracket is drawn, front view and top view, the side view of L-shaped bracket is also drawn with an L shape. Side view will show the L shape, and after that the rib should be added to that part. So rib, as we discussed in the earlier slide, the triangle portion of the rib, the triangular shape that is observed in the right hand side view is the true shape, and rest, the shape of the rib in the form of rectangle in the front view and top view, will be seen as the reduced shape. After drawing this, we have to give the respective dimensions in each view. So in this way, we are going to complete all the machine parts according to the guidelines we have discussed in the earlier slide. So thank you for watching this video.